Good afternoon, students. Today we are going to solve remaining problems in chapter 13. Okay, first exercise 13.1. Fifth problem. See what is given in the fifth problem. A hemispherical depression is cut out from the one face of cubical wooden block. What is given? Hemispherical depression is cut out from one face of cubical wooden block such that the diameter is L of the hemisphere diameter, base diameter is given L, which is equal to edge of the cube. So the diameter is equal to edge of the cube. So length of the edge of the cube is equal to diameter of the hemisphere of the base. Okay. Determine the surface area after removing the removing the hemisphere from the cubical bar. We have to find total surface area of the remaining solid. Okay. According to question, I will draw the figure, see, and after that we are going to solve the problem. Okay. See what is given from a cubical wooden block. This is cubical one wooden block. I have taken one cubical wooden block. From this cubical wooden block, we are removing a hemispherical part from one face of the cube. So like this. Hemispherical depression we are removing from one face of the cube. So whose diameter? This is the base of the hemisphere. The diameter is given. The diameter is equal to L, which is equal to the edge of the cube. Diameter of the hemisphere is equal to edge of the cube. So length of the edge of the cube is L and diameter of the hemisphere is L. So this is given information. According to information, I have drawn the figure. Now what we are going to find here, we are going to find total surface area of the remaining solid after removing this hemisphere from the one face of the cubical part. So how to find the total surface area here? First of all, I will find total surface area of the cube. Okay, total surface area of the cube, and I will add the CSA of. We are removing the hemisphere from this cubical part. So after finding the total surface area of the cube, add the CSA of the hemisphere. Then after remove the base. Why? Because here there is no part. We are removing the hemisphere now, so we have to subtract this base area. Only we have to find this area, which is CSA of hemisphere, and this part, remaining part, and total surface area of the cube also. Okay. So according to question, I am going to solve this. Given diameter of base of hemisphere is L. Then if base is L, diameter is L, then radius of hemisphere is R is L by 2. Because diameter is L now, so it is L by 2. And edge of the cube is edge of cubical block or cube. Edge of the cube is, I am taking edge as A, is equal to diameter of the hemisphere, which is given in the question. So A, side length A, I am assuming as A, which is equal to L. Right? Now I am going to find total after removing the hemisphere from this cube, we are going to find total surface area of the remaining solid. Okay. So how to get total surface area of the remaining solid? Total surface area of remaining solid. After removing the hemisphere from one face of cube or cubical block. How to get cubical block? That is equal to, first I will take the total surface area of cube plus I am adding CSA of hemisphere. CSA of hemisphere. Then I will remove the base area of the hemisphere minus base area of the hemisphere. Base area of hemisphere. Okay, right. Now what is the formula of TSA of cube? TSA of cube is 6a square. Total surface area of the cube. A is edge of the cube. Plus what is the CSA of hemisphere? 2 pi r square. Right? What is the base area? Pi r square. Base is the shape of circle, no? So circle area pi r square. Now I will substitute the given values. A. What is A? It is edge of the cube. What is given in the question edge is L. So 6L square plus 2 pi. Here R is radius of the hemisphere. Already L is diameter, so radius is L by 2 whole square minus see here 2 pi r square minus pi r square, automatically pi r square. So I will write pi r square here, then after I will substitute here 2 pi r square minus pi r square, pi r square. In place of r I substituted L by 2. Now simplify. I am taking L square outside. Take L square outside. By taking L square outside, this is 6 plus pi by 4. 6 plus pi by 4 is the remaining solid surface area. This is the remaining solid. L square I have taken common. So here you will get 6 and here you will get pi by 4. Pi into 1 by 4, pi by 4. So this is the total surface area, the area of the remaining solid. L square into 6 plus pi by 4 centimeter square. Okay, right. Now see 6th question. A medicine capsule is in the shape of cylinder. Already figure is given here. Right? A medicine, this is the medicine capsule is in the shape of cylinder with 2 hemispheres stuck at ends of the cylinder. 2 hemispheres stuck to each of its ends of the entire capsule. This is the capsule. We have 2 hemispheres stuck each ends of the cylinder. Here total length of the capsule is given, that is 14 millimeters total length of the capsule. And diameter of here, this is the diameter of the hemisphere. Diameter is also given, that is 5 millimeters. What we are going to find? We are going to find total surface area of this capsule. So see the figure. To find the total surface area of the capsule means we are going to find this total area. Total surface area of this capsule. So what I am doing, I am dividing this capsule into 2 hemispheres and 1 cylinder. So to find this total surface area of the capsule, we have to find this area, which is CSA of cylinder. Okay, these 2 areas are known as CSA of cylinder, and I am adding this CSA of hemisphere, CSA of hemisphere. So how to get capsule area? Total surface area is equal to CSA of cylinder plus CSA of 1 hemisphere plus CSA of 1 hemisphere. Right? Total length of the capsule is what? 14 millimeters, and phi is what? Diameter of the hemisphere. 5 by 2. It is a radius. So half pi. So this is also radius. 5 by 2. See, this is the hemisphere, no? This is the radius and this is diameter. So this is 5 by 2 up to here 5 by 2. From here to here 5 by 2. Why? Because this is the radius. Already we have the diameter. Diameter is 5. If you divide diameter by 2, you will get the radius. So this is 5 by 2 and this is also 5 by 2. So to get length of the cylinder part, this cylindrical part, no? To get length of the cylindrical part, we have total length of the capsule. But I am going to find length of the cylindrical part. See here, remove 5 by 2 at left right hand side, and here also 5 by 2 right hand side. 5 by 2 plus 5 by 2, 5. So we have to remove 5 from 14 millimeters. 5 millimeters from 40 millimeters. If you subtract, then you will get 9 millimeters. 9 millimeters is the length of the cylindrical part. Okay. So what we are going to find? We are going to find total surface area of this capsule. According to question, first of all I will find the length of the cylindrical part. Okay. Given, first write down given total length of capsule. What is length of capsule? 14 millimeters. And diameter of hemisphere is equal to 5. Radius r is equal to 5 millimeters is the diameter of the hemisphere. So if you divide it by 2, you will get the radius of hemisphere. Now I am going to find length of the cylindrical part. First, length of cylindrical part. Length of cylindrical part. Length of cylindrical part. How to get this length of cylindrical part? From total length of the capsule. Total length of capsule. From total length of capsule, subtract one radius of the hemisphere and another radius of the hemisphere. So 2 into r. 2 radius. Here left hand side 1 radius, right hand side 1 radius. If you subtract from 14 millimeters, automatically you will get length of cylindrical part, which is known as height of the cylindrical part. Okay, length means it is we can consider the height. So I am taking this as h. H is equal to total length of capsule is 14 minus 2 into r is 5/8. So 2 cancel. 14 minus 5, 9. 9 millimeters is the height of the cylindrical part. Now I got height of the cylindrical part. Okay, right. After getting height of the cylindrical part, now I am going to find total surface area of the capsule. Now see here, total surface area. Total surface area of capsule. Total surface area of the capsule. How to get? CSA of cylindrical part. To the CSA of cylindrical part, I am adding twice of CSA of hemispherical part. Right? So this will give total surface area of the capsule. What is CSA of cylindrical part? What is the formula? 2 pi RH. 2 pi RH is the CSA of cylinder formula. 2 pi RH plus 2 into CSA of hemisphere is what? 2 pi r square. Hemisphere CSA 2 pi r square. Now 2 into pi into what is r value? 5/8. What is the length? What we got? Length of the cylindrical part 9. Okay. Here 2 cancel plus 2 to the 4 pi r square again 5/2 whole square. Okay. So here now let us simplify this. 5 9s are 45. 45 pi. Here 5 5 is 25 by 4. Plus 4 into pi into 25 by 4. 4 cancel. 45 pi plus 25 pi. 45 plus 25. 70 pi. 70 pi centimeter square is the total surface area of the capsule. Therefore, total surface area of capsule is equal to 70 pi millimeter square is the total surface area of the capsule. Okay, right.